Good morning, students. Welcome in next lecture of Math F242 Operation Research. So in last class, we have started inventory system or inventory management, inventory control, where we manage the items in stock which arises due to the difference between the inflow and outflow, which are generated through demands and the supply of procurement. So in last class, we have covered few basic elements. In that, we have covered the cost and the salvage value and the salvage cost. So is there any doubt to understand that? What is the procurement cost, holding cost, shortage cost, and the salvage value, salvage cost? So now next is important because inflow, outflow generates due to the demand, and we know that customers are most unpredictable person. So here we can say that demand is most unpredictable or probabilistic or stochastic in nature, and here demand of an item may be deterministic or may be probabilistic. Means sometimes we assume that it is a deterministic, means after the fixed period we require the fixed number of item demand, or it may be the stochastic in nature or probabilistic in nature. So if we have the deterministic case, so we assume that the quantities needed over the subsequent time period are known with certainty. Means when and how much we require, that we know with certainty, then we say demand is deterministic. It can be of two type. It can be of two type. It can means it is classified as static or dynamic demand. Static demand means the known demand over the different period of equal length may be the constant, which is called static demand. So for the different period of length, if we know the demand, what is the demand, so then we say it is a static demand, it is a constant. So then we say it is a static demand. In the dynamic, this demand is vary. The demand may vary from period to period, but not known, which is called the dynamic demand. So in this case, we have the variable demand in the different period. Then we say it is the dynamic demand. As we have the category for the static demand, we have the category for the probabilistic demand also, that is stationary and non-stationary. In case of the probabilistic demand, we should know we should know which distribution the demand is following. So if you know the probability distribution for the demand, then it is the stationary. If you do not know the probability distribution, means if it is not following some particular pattern, well-known distribution, then we say it is the non-stationary demand. So we can have, when we develop the inventory system, so first we have to recognize which type of the demand we have. So demand can be satisfied instantaneously by purchasing the amount items from the market, or uniformly by producing, right, by producing those items, required items, in-house facility. So when we have the production system, at that time we satisfy the demand uniformly. When we have the purchasing system, then we satisfy the demand instantaneously. Just you go to market and purchase whatever the required demand. Then we have the ordering cycle. So you have seen we have the continuous purchase or procurement, then storage, then the outflow, which due to the demand, then we have to again the purchase. So this cycle will repeat. Means here we have purchased, then after the purchasing uniformly, right, or purchase, then we use, then again purchase, then we use. It can be either we produce, then use, then produce, then use, then produce, then use. So you can see that here the inventory level with time is changing. So this this pattern is repeating again and again. So this pattern is known as the ordering cycle. Means when we are giving the new order, when we are making new procurement. So this time period between the receipt of the two successive order, means this time period are known as the ordering cycle. Means the time between the two consecutive orders are known as the ordering cycle. Then we have review policy. Any system, any control system cannot be perfect, right? Always we have the flaw or imperfection. So with the time, right, with the time we have to review so that we can change our policy. So that procedure are known as the review policy. The inventory system may be broadly classified as continuous review system or the periodic review system. Means either we can review our studied system continuously. Means over the continuous time we are reviewing, or we fix some particular period. For example, on every Sunday we will analyze the output of the last week. So that is the periodic, or we can review continuously. So a review policy can be either the continuous or periodic in nature. In continuous review system, the system is monitored continuously over the time, and in periodic review system, the system is monitored at the discrete, equally spaced instance or the time. So we can have the review policy as per our studied model. We can decide which type of the review policy we want, or which type of the review policy is required, which type of the monitoring is required. So in both policies, the aim would be to keep the inventory at a desired level. Means whatever the review policy you are opting, the objective the objective in reviewing is whether we are able to satisfy the customer or not, whether we are able to justify the demand or not on time. So with that, thereafter we have the lead time. Lead time is the time difference between the order and actual receipt of the procured item. Means when for example you are procuring today, you have ordered some item. For example, you have ordered your mobile today. So after 2 days you are getting. So these 2 days are known as the lead time. So here the time between the placement of order and the receipt is called delivery lag or lead time. Lead time is the time difference between the time of order and time of receipt. So whenever you require your item at the particular point of time, so if there is some time lag in receiving the item, you have to order little prior than the or prior to the required time, so that at the required time you have the required items in your inventory. So that is the means very important thing you have to consider in your procurement. So the order may be delivered instantaneously, or it may require some time before the delivery starts. So that come under the delivery time or lead time. So lead time it can also be the deterministic. We know it takes the exact 2 days, exact 3 days, exact 4 days, or it is a deterministic, or it may be the probabilistic. It may take the 2 to 3 days. It may take 3 to 4 days. So it is the probabilistic. So when we have the probabilistic, we have to go with the some probability distribution. Then we have the stock replacement. Means whenever we have the demand, so we are utilizing the inventory. Means inventory is decreasing. So by some mean we have to replace the inventory. So that is the stock replacement. The actual replacement of the stock may occur instantaneously or uniformly. Instantaneously means by purchasing the item from the market, or uniformly means by producing the item in in-house facility. So instantaneous replacement occurs when the stock is purchased from the outside source. When purchased from the outside source, then we say it is the instantaneous stock replacement. In this case, delivery rate is said to be infinite. This thing you have to remember. When we have the stock replacement instantaneous, then we take the delivery rate as a infinite. When we have the uniform replacement, that occur when the item is produced right locally in in-house facility within the organization. Then we have the time horizon. So time horizon defines the total period over which the inventory level will be controlled. Means it may be the long time. For example, we have the grocery shop. So continuously over the year, we have that's the same grocery shop, but it may be of limited period. For example, Rakhi business, Diwali business, calendar business, Christmas business, all are the limited period business. So there the time horizon is limited. So it may be infinite, it may be the finite. So the time horizon may be finite or infinite. Then sometimes we have the business, sometimes we have to manage the inventory of one items or multiple items, number of items. And number of items has the constraint, right? Constraint of the space, constraint of the money, constraint of the demand. So depending over the different management system, the we have to consider the number of items is also one important factor. It may be one, it may be more than one. So multiple item, we have to care about the interaction between the different items. For example, if you are selling the toothbrush, so you have to sell the toothpaste also, right? So that type of the combination we have to take care. So as I've told you, when we are studying the inventory system, we have to take care about the two things. So here when the order quantities are more, when we order, right, order in more quantity, then naturally the holding cost will increase. Holding cost will increase, right? When we order less, when we order less, so here we have to this is the curve of the ordering cost. So we have to manage the balance between the ordering cost and the holding cost. We have to manage the balance between the ordering cost and the ordering cost and the holding cost, so that here we have the minimum, right? So that quantity, that how much we should order q star, we have to compute, so that total cost of holding plus ordering should be minimum. So so these are the basic components for the inventory control or inventory system. Thereafter, we will go with the different model. So total we have the four basic models. Fifth one is the modification of the these four one. Then after we have the two more model. So first five models are deterministic in nature, and last two models are probabilistic in nature. So here we will start from the model third. Then after we will go with the model one and model two, and then model four. So in the model third, now first you clear whether all the basic components is clear to you or not, because now those terms we have to use. So we have studied the procurement cost, means in the procurement cost we have studied the setup cost, right? Purchase cost, then holding cost, shortage cost, then salvage value, salvage cost, then demand, stock replacement, review policy, lead time, time horizon. So is there any doubt in all these terms? Okay, great. I feel there is no doubt. So now let us start with the model third, the single item. As I've told you, we can have the number of items also. So here we are taking the single item. Static demand means demand is deterministic. It is the deterministic, and in the deterministic also it is the static. Means for the different period, for the different period we know the demand, in advance with the certainty. Then production model means here we have the uniform stock replacement. It means we have the uniform stock replacement with back ordering means shortage are allowed. You have seen we have the two type of the shortages, either no backlogging or with backlogging. So here we are considering the with back ordering. And in this case, when we have the production model, so it is given to you, we have the constant delivery rate. We have the constant delivery rate, and the constant delivery rate is given to you as a. And we have the constant demand rate, and it we denote it by the D. Naturally naturally delivery must be greater than the demand, otherwise there is the explosion of the demand. You never able to fulfill, right? You never able to fulfill the demand. So always the delivery rate delivery rate must be greater than the demand rate. As you have seen in the queuing system also, the service rate must be greater than the arrival rate, otherwise there is the explosion of the customer. Here we have the explosion of the, right, explosion of the demand. If the delivery rate is not greater than the demand. Clear? So always we have to consider the delivery rate must be greater than the demand. So here we have the following assumption for this model. As I have explained from the title, the demand rate, usage rate in units per unit time is constant D. Means here we have the constant demand. Stock arrive, right? We have considered the production model. So stock arrive or produce at a constant rate A until the complete order is received. Always we have the finite capacity in the inventory. We cannot continuously produce. Always we have the constraint. So whatever the maximum constraint, up to that we maintain the production system. As we have the sufficient inventory, we stop the production. So as A, the number of units of item produced or delivered per unit time, the arrival rate A must be greater than the usage rate D to avoid the unfilled demand. That is, A must be greater than D. The back order allowed, the maximum shortage or back order allowed, that limit is the B. Means more than B demands we cannot afford. The shortage of more than B items we cannot afford. So it is the level of the affordness. So level at which the production run, means at that time you have to start, you are now want to start the production system. Means more than that you cannot afford the shortage. The replacement of the stock is accomplished using the SS policy. SS policy is the limit when the it is the lower limit. It is the lower limit when lower limit when the stock or production should start. Production should start. Production should start. So it is the lower limit when we have to start our production system, and S is the maximum limit. S is the maximum limit when we have to stop the, right, maximum limit to stop the production system, to stop the production. So here we follow the SS policy. So in this case, you can see when we start the production, when the small s is minus b, means minus b, that is the maximum allowed shortages. Maximum allowed shortages. Clear? And lead time is zero. Here we consider the lead time is zero. What is the lead time? The time between actual order and actual receipt of the items or goods. Then we say it is the lead time. So here we are assuming that as we have ordered, immediately we are getting the items. So lead time is zero. Time horizon is infinite. Means this we are considering for the continuous time period. Clear? Or any doubts? All the basic assumptions are clear to you. So, is there any doubt? So now we have to make the model. So in this case, what we have studied till now, that this is our the graph between the time and the inventory level. This is the inventory level. Here we have the inventory is zero. Here we have the positive inventory. Here we have the negative inventory. Negative inventory means we are in shortage. There is a demand, but we are not able to supply. So that we say we have the negative inventory. So let us assume we have the, let's say it is the minus b, or you can say s, and this is the maximum limit capital S, where we stop our production. So at this point we are starting our production, and since since delivery is constant, so here we have the increase in the inventory level. Here we have increase in the inventory level. Then as you have the S item in your inventory, then you have to stop your production system. There is only the demand. So here we have the demand, and it is given to you. Demand is also constant. Demand is also constant. So as with the constant rate, due to the demand, the inventory level will decrease. So inventory level will decrease. At this point, the inventory level is zero, right? At this point, inventory level is zero. After that, we have the continuous demand, but we are not able to supply. Then we face the shortage. So up to the minus B, we maintain the shortage. Then after again we start our production, right? Then again we, so this way we have the continuous cycle up to the uh, infinity time, because the time horizon is given to you as a infinite. So this is the continuous cycle. So here we can divide, this time as a t1, this time as a t2, this time as a t3, and this time as a t4. So in the t1, what is happening? We have the production as well as the demand, because demand is continuously rising. So we have the production as well as the demand, and with that production we are satisfying the shortages. We are satisfying the shortages. In the T2 period, we have the continuous production, continuous demand, and we are managing the positive stock. We are increasing, we are replacing our stock, right? So here the inventory level will become the positive. In the T3 period, there is no production, only demand. So due to the demand, the inventory level will decrease. Then in the T4 period, we have the continuous demand, but we are out of stock. So just we are maintaining the shortages. So with the continuous demand, the shortages will increase, or inventory level will continuously decrease. So that is the T1, T2, T3, T4. So here we have the T1, the time period during which arrival continues, right? Means there is the uh, arrival continues until the shortage is over, from B to 0, from B to 0. Then T2 is the time period during which arrival continues until the complete order is received from 0 to S. Means we continue the production system until our inventory level reaches to the S. Then time period during which arrival stops. Means as you achieve your maximum limit of inventory or maximum inventory level, then you have to stop your production, and just usage is continue. And here with the usage is continue with the demand rate D, and the inventory level decrease from S to 0. And in the time T4, time period during which usage continues with the rate D, right, from 0 to B. So at the end of the T4, reorder is to be made. At that time, we have to reorder. So that cycle will repeat. So here I have explained this graph. Now, during the T1, what will happen? There is a production with the constant rate A, and at that time we will satisfy the unfilled order. Means we satisfy the shortages. At that time we satisfy the shortages. The unfilled order, back order, are filled with the rate A minus D after meeting the demand arising at the rate D. Means in this period, what is happening? In this period, what is happening? That we have the production with the rate A, we have the demand with the rate D. So never we do like this. We are not satisfying the current demand. always if we have the item, we always satisfy the demand. It means that A minus D is the actual production, actual, right, arrival rate. A minus D is the actual arrival rate of the item. So with the A minus D in the period type T1, in the period T1, able to satisfy the all shortages. That is the, we have the shortages of the B item. So A minus D into T1 is equal to B. Clear this part? Similarly, in the T2 period, in the T2 period, right? In the T2 period, again, we have the actual replacement rate as A minus D. A is the production rate, D is the demand rate, right? So after satisfying the current demand, we have the rate of increasing the inventory is A minus D. So in the period T2, in the period T2, you are able to stock the S level. You are able to stock the S level. Means here we have the S is what? Maximum inventory level, maximum allowable inventory level. So at that time you are able to manage the S item with the rate A minus D. In the period T3, in the period T3, there is no production, only the demand, only the demand. And in the period T3, you are able to finish all available S items. You are able to finish all the S item. So D into T3 is equal to S. Then in the period T4, in the period T4, we have the continuous demand with the rate D. And up to when we can manage the shortages, that limit is the B. So here DT4 is equal to B. So that is the our different events in the different time period. Clear? So here we have the S is equal to A minus D into T, and D3 is equal to S, and B is equal to DT4. Yes, someone is asking.
Hello. Hello. Sir, can you explain during the period T2?
In the T2, what we have, this label is the S. This is the S. Assume that S is equal to 1000. So how we can, let's say production rate is equal to 150. Demand is 50. So when the production is 150, demand is 50. So it means actually you can stock only the 100 items. A minus D is equal to 100. So you want to stock the 1000 item. So for the 1000 items with 100 items daily, you require the 10 days. You require the 10 days, right? So for collecting the 1000 item. So that we are doing. A minus D into T2 is equal to S. Now clear?
Okay, sir. Okay, sir. Thank you.
Right? Means here we have the inventory level 0, 100, right? 10,000. Here we have the negative inventory level. Let 0, minus 50, minus 100, minus 200. That is the. Any other doubt? Anyone? Now, from here, if Q is the quantity ordered or produced in one cycle, in one order cycle. So, how much quantity you have ordered? The quantity you have ordered, whatever you have utilized in this period, right? So let Q is the quantity produced, that quantity, whatever you have produced in this period, right, that quantity is equal to the quantity in inventory, quantity to manage the shortage, quantity to manage the current demand. That whatever the production you have done in this period, with that you can manage the shortages, you can manage the positive inventory, and you can manage the current demand also. So it means, let's say this time period is t naught. It means q, q is the quantity, right? Q is the quantity. So here q is the total production quantity. So that is equal to, q is equal to d into t naught. Means means here, why I am writing the q is equal to d t naught, because in this period we have the current demand, we have the shortages, means back order demand, we have the positive inventory, right? So all you are utilizing through the demand only, right? So in this period, in the t naught period, we have this much demand which we are producing. So q is equal to dt naught. It includes the current demand, it includes the backorder demand, right? It includes the positive inventory level, it includes the negative inventory level. Means here, when we have started our production system, at that time the level is minus b. When we have to restart our production system, then also we have the minus b. Means whatever we have produced, that we have utilized to satisfy the demand in the period t naught. So that's why q is equal to d into t naught. So in this case, what is the t naught? So from the figure, if you observe, t naught is what? T naught is the t naught plus t1 plus t2 plus t naught is equal to t1 plus t2 plus t3 plus t4. Now, one more thing, where we have the q, right? Q is what? Total production quantity. Q is what? It is the total production quantity. Total production quantity. So where you are producing? You are producing only in this period. You are producing only in this period. So here Q is equal to what? Q is equal to A in period T1 plus T2. That is our total production. Total production quantity means it is the delivery rate, constant rate in the period T1 and T2. T1 and T2. So here it is given to you, Q is equal to A into T1 plus T2. Now from the first and second, if you see from here, T1 is what? T1 is B upon A minus D. T2 is what? T2 is the S upon A minus D. So if you do the T1 plus T2, T1 plus T2, if you add first and second, so it will give you, if it will give you B upon S, B upon A minus D minus or plus S upon A minus D. That is the 1 upon A minus D is equal to B plus S, and it is the T1 plus T2. So in this case, we have the B plus S is equal to A minus D into T1 plus T2. So that is written here. So from the first and second, B plus S is equal to A minus D into T1 plus T2. So from here, S will come A minus D, right? A minus S is equal to, this will implies S is equal to A minus D into T1 plus T2 minus B, right? It will be the S is equal to A minus D into T1 plus T2 A minus D. And this T1 plus T2 we can write from here as a Q upon A. So this will be the Q upon A. So here we have the S is equal to A minus D into Q upon A minus B. Clear? So if you take A common, right? So A, it will give you 1 minus D upon A, Q upon A minus B, and A cancel. So here we have the S is equal to 1 minus D upon A into Q minus B. Similarly, here from here we can write T3 is what? T3 is the S upon D and T4 is the B upon D. So if you do the T3 plus T4, T3 plus T4, so S upon D plus B upon D. So this will give you S plus B is equal to D T3 plus T4. Now now we compute the holding cost. So in which period we have to hold? In which period we have to hold? You have seen for the total cost we have to compute the procurement cost, holding cost, shortage cost. So in which period you have to hold?
T2 plus T3.
In the period T2 plus T3 we have to hold, right? So what is the basic formula of the holding cost? What I have told you, it is the A to B, right? A to B inventory level dt into unit cost, right? C1 is the unit holding cost, means cost to hold the unit item for the unit period. So for this period it will be the C1, right? And here we have to hold from 0 to T2 plus T3. So it is the 0 to T2 plus T2 to T2 plus T3. Now in this case, how the inventory level is increasing? How the inventory level is increasing? In the period of T2, how many items are increasing? In the period of T2, how many items are increasing? S item. So rate will be the S upon T2. So as time increase, the inventory level is S upon T2 into T. So that is the inventory level with the time T into dt. Now in the period T2 to T2 plus T3, what we are doing? We are utilizing the all S item, right? So all S item. So what is the rate of utilization or rate of usage? S item in the period T3. In the period T3, so how the inventory level is decreasing at the T2 plus T at the at the T2 we have the S item. As time increase, it is decreasing. So T2 minus T3, right? T2 plus T3 minus T. At that time, we can say what is the available inventory level, right? Available inventory level into dt. So that is the holding cost. Means this is the IT IT in the period 0 to T2, and this is the IT in the period T2 to T2 plus T3. So, and C1 and C1. So C1 S upon T2, you can take common, integrate T square by 2, 0 to T2 plus S upon T3, you can take common, integral T2 plus T3 into T minus T square by 2 from T2 to T2 plus T3. Clear? So this will come C1 S upon T2 into T2 square upon 2 plus S upon T3, and this is the T2 plus T3, and it will be the T2 plus T3 minus T2 minus minus T2 plus T3 whole square minus T2 whole square divided by 2. So T2 and T2 cancel out. So C1 as T2 upon 2 plus S upon 3. Here we have the T2 and T2 cancel out, and here T3 and T3 is cancel out. T3 and T3 is cancel out. So here we have the S into T2 plus T3 plus S upon T3, right? S plus S upon T3, or you can say minus, and here we have the T2 square plus T3 square plus 2 T2 T3 minus T2 square upon 2. So here we have the T2 is cancelled with the T2 square, T2 square is cancelled with the T2 square, and T3 cancel with here. So in this case, we have the minus S T3 minus 2 T2 upon 2 upon 2, and here we have the S also. So 2 and 2 cancel out, plus ST2 plus ST3 plus ST2 by 2 into C1. So here we have the negative ST2, here we have the positive ST2, that is cancel out. So from here we have the C1 S by 2 common, T2 plus T3 from here, and right from here. So C1 into S by 2 into T2 plus T3. Clear this part? And T2 plus T3 we have already derived as, right? So this we have derived S into T2 plus T3 into C1 upon 2, and T2 plus T3 here we have derived as T2 plus T3, here we have derived as the B plus S upon A minus, oh no, T2 plus T3. Just wait a bit. So here we write the C1 S upon T. What is the T2? T2 from the slides we have seen T2 is equal to T2 is equal to from here T2 is S upon A minus D. T3 is the S upon D, right? So S upon A minus D and S upon D. So when we write that S upon A minus D plus S upon D, that is the T2 plus T3. So C1 S square by 2, and here we have the A minus D, A minus D into D, D plus A minus D. So here we cancel this. So here we have the C1 S square A upon 2 A minus D upon D, that we have. And what is the value of the S? Or you can write it as a C1 S square upon C1 S square upon 2. If you take A common, so it will become 1 minus D upon A, D upon A D into D. So that A is cancel out, right? A from the numerator is cancel out. And what is the value of the S? S just now we have computed as C1 S we have computed as A minus D upon Q minus A minus B, right? So 1 minus D upon A Q minus B. So that we write here. So C1 1 minus D upon A Q minus B whole square upon 2 1 minus D upon A into D. So that is the holding cost. So in next class we continue with the other costs.